sentences, syntax. Let's first understand what syntax is. Syntax is the grammatical structure of sentences. In the given example, this can be interpreted as syntax, and it is similar to the ones you use while writing codes. Knowing a language includes the power to construct phrases and sentences out of morphemes and words. The part of the grammar that represents a speaker's knowledge of these structures and their formation is called syntax. Phrase structure rules are rules that determine what goes into a phrase, that is, constituents of a phrase, and how the constituents are ordered. Constituent is a word or group of words that operate as a unit and can be used to frame larger grammatical units. The given diagram represents that a noun phrase is determined when a noun is combined with a determiner, and the determiner can be optional. A sentence is determined when a noun phrase is combined with a verb phrase. A verb phrase is determined when a verb is combined optionally with the noun phrase and prepositional phrase. And a prepositional phrase is determined when a preposition is combined with a noun phrase. A tree is a representation of syntactic structure of formulation of sentences or strings. Consider the given sentence. The factory employs 12.8% of Bradford County. What can be the syntax for pairing this statement? Let's understand this. A tree is produced that might help you understand that the subject of the sentence is the factory. The predicate is employs, and the target is 12.8%, which in turn is modified by Bradford County. Syntax parses are often a first step toward deep information extraction or semantic understanding of text. Rendering syntax trees. Download the corresponding .exe file to install the Ghost script rendering engine based on your system configuration in order to render syntax trees in your notebook. Let's understand how you can set up the environment variable. Once you have downloaded and installed the file, go to the folder where it is installed and copy the path of the file. Now go to System Properties, and under Advanced Properties, you will find the Environment Variable button. Click on that to open the pop-up box tab of the environment. Now open the bin folder and add the path to the bin folder in your environment variables. Now you will have to modify the path of the environment variable. Use the given code to test the working of syntax tree after the setup is successfully installed. Structuring sentences, chunking and chunk parsing. The process of extraction of phrases from unstructured text is called chunking. Instead of using just simple tokens which may not represent the actual meaning of the text, it is advisable to use phrases such as Indian team as a single word instead of Indian and team as separate words. The chunking segmentation refers to identifying tokens, and labeling refers to identifying the correct tag. These chunks correspond to mixed patterns in some way. To extract patterns from chunks, we need chunk parsing. The chunk parsing segment refers to identifying strings of tokens, and labeling refers to identifying the correct chunk type. Let's look at the given example. You can see here that yellow is an adjective, dog is a noun, and the is the determiner, which are chunked together into a noun phrase. Similarly, chunk parsing is used to extract patterns and to process such patterns from multiple chunks while using different parsers. Let's take an example and try to understand how chunking is performed in Python. Let's consider the sentence, "The little mouse ate the fresh cheese," assigned to a variable named cent. Using the word tokenize function under NLTK corpora, you can find out the different tags associated with the sentence provided. So, as you can see in the output, different tags have been allocated against each of the words from the given sentence using chunking. NP chunk and parser. You will now create grammar from a noun phrase and will mention the tags you want in your chunk phrase within the function. Here you have created a regular expression matching the string. The given regular expression indicates optional determiner followed by optional number of adjective followed by a noun. You will now have to parse the chunk. Therefore, you will create a chunk parser and pass your noun phrase string to it. The parser is now ready. You will use the parse parenthesis parenthesis within your chunk parser to parse your sentence. The sentence provided is "The little mouse ate the fresh cheese." This sentence has been parsed and the tokens that match the regular expressions are chunked together into noun phrases, NP. Create a verb phrase chunk using regular expressions. The regular expression has been defined as optional personal pronoun followed by 0 or more verbs with any of its type followed by any type of adverb. You'll now create another chunk parser and pass the verb phrase string to it. Create another sentence and tokenize it. Add POS tags to it. So the new sentence is, "She is walking quickly to the mall," and the POS tag has been allocated from NLTK Corpora. Now use the new verb phrase parser to parse the tokens and run the results. You can look at the given tree diagram, which shows a verb parser where a pronoun followed by two verbs and an adverb are chunked together into a verb parse. Structuring sentences, chinking. Chinking is the process of removing a sequence of tokens from a chunk. How does chunking work? The whole chunk is removed when the sequence of tokens spans an entire chunk. If the sequence is at the start or the end of the chunk, the tokens are removed from the start and end, and a smaller chunk is retained. If the sequence of tokens appears in the middle of the chunk, these tokens are removed, leaving two chunks where there was only one before. Consider you create a chinking grammar string containing three things: chunk name, the regular expression sequence of a chunk, the regular expression sequence of your chink. Here in the given code, we have the chunk regular expression as optional personal pronoun, followed by 0 or more occurrences of any type of the verb type followed by 0 or more occurrences of any of the adverb types. The chink regular expression says that it needs to check for the adverb in the extracted chunk and remove it from the chunk. Inside the chinking block with open curly braces and closing curly braces, you have created one or more adverbs. You will now create a parser from nltk.regexp parser and pass the chink grammar to it. Now use the new chink parser to parse the tokens sent3 and run the results. As you can see, the parse tree is generated. While comparing the syntax tree of the chink parser with that of the original chunk, you can see that the token is quickly, adverb, chinked out of the chunk. Let's understand how to use context-free grammar. A context-free grammar is a four-tuple sum NTRS where sum is an alphabet and each character in sum is called a terminal. NT is a set and each element in NT is called a non-terminal. R, the set of rules, is a subset of NT times the set of sum UNT. S, the start symbol, is one of the symbols in NT. A context-free grammar generates a language L capturing constituency and ordering. In CFG, the start symbol is used to derive the string. You can derive the string by repeatedly replacing a non-terminal on the right-hand side of the production until all non-terminals have been replaced by terminal symbols. Let's understand the representation of context-free grammar through an example in context-free grammar. A sentence can be represented as a noun phrase followed by a verb phrase. Noun phrase can be a determiner, nominal. A nominal can be a noun. VP represents the verb phrase. A can be called a determiner. Flight can be called a noun. Consider the string below where you have certain rules. When you look at the given context-free grammar, a sentence should have a noun phrase followed by a verb phrase. A verb phrase is a verb followed by a noun. A verb can either be saw or met. Noun phrases can either be John or Jim,